So very good evening to one and all present here. I welcome all of you for Module 2 Engineering Mechanics of today's session. The last Module 1, the yesterday presentation, we have started the basics of statics and dynamics in engineering mechanics. Then what are the different types of the dynamics, say kinetics and kinematics. Then what are the different system of forces, say coplanar and non-coplanar forces. I think with that, up to that, we have ended our the previous day, the lecture. Now today, we are going to see about the module 2 from the same subject, engineering mechanics. So today, we are going to discuss about the law of mechanics. So in that, we are going to touch upon the Newton law of motion, the first law, second law, and third law. That the law of transmissibility of forces, parallelogram law of forces, and triangular law of forces. So these things we are going to start in the module 2. Similarly, in module 3, we are going to continue in the next meeting after completing this module 2 today. Now let us start with the Newton first law of motion. So take a rigid body A, okay, so which is subject to rest at a particular point. Now consider two forces F1 and F2 which are equal in magnitude acting in the same line of action. Okay, so as per Newton first law, any body will retain its same position until and unless a force which acts on the body. Otherwise, it will not change its motion. It will be at the same state of position. So an object will not change its motion unless the force acts upon it. So this is what the Newton first law describes the statement. Okay, so let us explain with the help of the graphical illustration. So consider an example. There are two forces F1 and F2 facing opposite to each other, the same direction. It is assumed that the object A is at rest before the application of the forces. Now, after applying two forces on either side of the object A, the sum of the forces given by the formula F1 plus within bracket minus F2 is equal to 0. So minus F2, that minus symbol that represents the force F2 acts in opposite to F1. So we are using minus sign, negative sign. The formula is F1 plus F2, sum of the force is equal to 0. So here the force F1 cancels out the force F2. So the net resultant force is 0. So this clearly states that there is a proper balance between the forces applied on the object. So the object A is continued to be at rest in the same position. Okay. So this is what the first law, the Newton first law, clearly states out. Then second law of motion, Newton's second law of motion. Here, the force which acts on an object is said to be equal to the mass times its acceleration. It is simply say F is equal to m into a. It is a mathematical relationship. Applied force is equal to the mass of the body and acceleration due to the motion which produced by the body. So here, two forces are not equal. So one will be greater than the other one. So here, let us assume F1 is greater than compared to F2. The force F1 is greater than F2. So then in such case, we say that it is unbalanced. The two forces are unbalanced in nature. So thereby, the application of force continues the body to move and motion with a forward acceleration. So this is the mathematical equation which is expressed to define the Newton's second law of motion. F is equal to m into a, where m is the mass of the body and acceleration. And these are the corresponding unit scale dimensions that are given here. And what is Newton's third law of motion? So here, so for every action, there will be equal and opposite reaction. So this is what the third law states that. So let us take an example, a rocket engine. So the engine moves forward due to the backward thrust which is applied at the exhaust turbojet nozzle. So due to the backward thrust, it makes the rocket engine to move forward. So here, this is one of the best example for the Newton third law. Another example from the production technology, take a forging operation carried out in forging shop. So here, let us consider an operator operating a forging machine by keeping the workpiece on the table. So when the forging head is dropped down towards the workpiece, for every individual strike on the workpiece with the help of the forging head, there will be equal and opposite reaction. So what is the equal and opposite reaction? If you hit the forging head by dropping suddenly, by creating an impact force on the workpiece surface, so the geometry of the workpiece may get changed. So due to the dead impact force. So this clearly states that for every equal strike of the forging head, there will be opposite reaction that is produced on the workpiece surface by changing the geometry due to the physical, the deformation. So this is also we can take as one of the example for the Newton third law, the classical theory. Now, with all knowing about the first law, second law, and third law of Newton, now we will see about Lami's theorem. Here we are going to see a small numerical problem. Before that, so we will see the statement of Lami's theorem as defined here. What exactly the Lami's theorem proposes? Consider three forces Fa, Fb, and Fc. All the three forces are acting at a point O are considered to be in equilibrium. Then in that case, each force is proportional to the sine of the angle between the other two forces, where alpha, beta, gamma are the angle between the each force pair. So how to derive the equation? F1 by sine alpha is equal to F2 by sine beta is equal to F3 by sine gamma. So from the statement it is given that all the three forces are proportional to the sine of the angle between each other. So in that way, the equation has been formed. Now we are going to test this equation with the help of the simple numerical problem. So consider three non-collinear coplanar forces F1, F2 and F3, which is acting at a particular point on a rigid body. The angles opposite to the forces F1, F2 and F3 are said to be 80 degree, 130 degree and 150 degree. So the values of the forces F1, F2, F3 are said to be 20 Newton, 116 Newton and 25 Newton. Check whether these forces acting at a point are said to be in equilibrium using Lami's theorem. So we are going to theoretically verify with the help of the above equation whether these F1, F2, F3 are equilibrium state which are acting at a same single point. Now, draw the solution for the given problem. Take a rigid body, okay? right? So F1, F2 and F3 are the three forces acting on the rigid body at a same point. A, B, C are the angle between the forces. So A equal to 80 degree, B equal to 130 degree, C equal to 150 degree. That is angle between F2 and F3, that is 80 degree alpha. In other ways, we can say A. Angle between F3 and F1 is 130 degree. Angle between F1 and F2 is 150 degree. So A, B and C are given here for the kind reference. Now, angle opposite to F1. So 80 degree, that is located opposite to the force F1. Angle opposite to F2, 130 degree. And angle opposite to F3, 150 degree. So these are the physical identification of the forces, the angular orientation of the force. Then as per Lami's theorem, so update the equation F1 by sine alpha is equal to F2 by sine beta. Sine, this is not sine alpha, sine A. So in the general formula, it has been defined as alpha, beta and gamma. According to our convenience, we can change the letter notation as AB is C. So F1 by sine A is equal to F2 by sine B is equal to F3 by sine C. Now, find out the force ratio. So take F1 by sine A, substitute in the given equation. F1 is equal to 20 Newton. Then A is 80 degree. Okay. So angle between the force F2 and F3, that is 80 degree. Okay. So sine 80. So substitute and find out the ratio. And here F2 by sine B, 16 by sine of 130 degree. So 20.886. So find out the ratio for the next combination. F3 by sine C, 25 by sine 150 degree. Okay, if you substitute, you will get 50. Okay, so these are the three force ratios. Okay, by applying the Lami's theorem equation, here we got it. Now, from this result, what is the inference? So it is clearly shown that no two pair of force ratios are not in equilibrium. They are not equal. So F2, F2, F1, F3 are not equal. They are not equilibrium. They are considered to be non-collinear, non-coplanar forces. So in today's lecture, we have discussed about the Newton law of motion, three different kinds, and we saw about Lami's theorem. So in the next module number 3, we will discuss the remaining law of mechanics, parallelogram law of forces, then triangular law of forces. So with this few introduction about module 2, so I thank each and every one of you. So we will meet in the next meeting with module 3. So thank you one and all.